Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 2 for this week. And today's topic is a suggestion given to me by one of my subscribers, and it's about weather balloons and whether or not what they do and whether or not we still need them or not. And the short answer to that is yes, we still badly need them. And it turns out that these weather balloons are basically a transport mechanism for radiosondes, which are a weather instrumentation package that is able to measure things as it goes up through the atmosphere, carried upward by the balloon. So let's take a look at some interesting facts here. There are over 800 locations around the world that launch these weather balloons and carrying the radiosondes upwards. 69 of those are in the conterminous United States. Now, they measure pressure, temperature, and humidity as they go up through the atmosphere and radio it back down to the ground. And then, by tracking the balloon, winds at various levels of the atmosphere can be calculated through basic trigonometry. Now, they are launched twice a day at 0Z and 12Z, which are Greenwich times. This time of year, we are 5 hours behind that. So that would be 7 p.m. and 7 a.m. local time. When we go to daylight saving time, we're only 4 hours behind. So that would then become 8 p.m. and 8 a.m. But these balloons are launched at a standard time all year round, and they don't recognize daylight saving time with Greenwich time. All right, so during major weather events, they will increase the frequency at which these balloons are launched up to 4 times a day, because one of the problems with these radiosondes is that the stations are pretty far apart. And so if you have a small-scale system, it can be missed either between stations or between times. And so the more launches you have, the better geographical and temporal resolution that you have, that you can pick up these little details. Now, all that data is then gathered and goes into all of the numerical models, not only in the United States, but around the world, and they can ascend to heights of 115,000 feet and can be carried almost 200 miles from the release point. Now, I have talked to people over the years that have seen these things land in their backyard, and there is a little note on it that says, if you find this, please return it to the National Weather Service so we can use it again. And it actually ends up saving them a little bit of money. The problem is only about 20% of the radiosondes are actually recovered and returned to the National Weather Service. All data is transmitted in what I think is a ridiculously complicated code, which I will share with you now. First, we have the mandatory levels, which are the levels that we take readings from every day no matter what. Even if there's nothing important going on at that particular level, we are going to get observations from those levels. And so this is an example of that, and the TTAA here means the significant levels, okay? Now, this is really wild. The 70, you subtract 50 from that, and you get the date. So that's January 20th. The 12 is the time, 12Z. The 72317 is the station ID number for Greensboro, and that's one of the 2 stations in North Carolina where we launched the weather balloons. The other one is down around Morehead City. And the 3 there, the higher that number is, the farther north the station is, and the bigger these 2 digits are, the farther west it is. So if it was like 580, then that would be farther north and much, much farther west. Okay, so the 99 means surface. The surface pressure is 978 millibars. The temperature is plus 9.4 degrees C. If this 0 was a 1, it would be minus 9.4 C. The 60, you subtract 50 from that and get 10. That's the dew point depression. And so you subtract 10 from the temperature of 9.4, and you get minus 0.6 for the actual dew point, okay? Now, this 0, 0, I'm sorry, and then the wind is from 300 degrees at 12, I believe it's 12 knots. Now, the 0, 0 means 1,000 millibars. Now, here's the problem. 1,000 millibars is 92 feet above sea level, and Greensboro is about 800 feet above sea level, so the 1,000 millibar surface is underground. And so we don't have any temperature and wind data, obviously, for that. Then we go up to 925 millibars, and this is the height above sea level. Temperature 6.4, dew point depression 9. Wind 295 degrees at 23 knots. And then we go to 850 millibars, 700, 500, 400, 300, 250, 200, 150, and 100. Then the 88 group is what we call the tropopause, which is where the temperature stops decreasing with height and starts increasing with height. So now we're going into the stratosphere, okay? And the tropopause in this particular case is 239 millibars, temperature minus 52.7 degrees C, and the wind, if you see a 6 here, you subtract 500 from it, you get 150 knots. So the wind is out of the west at 150 knots, sustained at that level. And then the 244, the 7-7 group, is 244 millibars. That's the maximum wind level. That's just about the same as the tropopause. And again, 270 degrees at 150 knots. There is some additional data here which we will not go into today. And then we have the significant levels, which are the levels at which something is changing, either with regard to the temperature or the humidity or the wind. And so that is transmitted to us in a group called TTBB. And the way this data is transmitted is that we have groups that are double digits of the same number. So you have 0, 0 here, and you get 978 millibars, 9.4, dew point depression 10, and then 1, 1, 2, 2, 3, 3, and it keeps going and repeats that sequence until you get all the way up to here where it's 100 millibars. Then when you see 2, 1, 2, 1, 2, that's the beginning of the wind data. So at 978 millibars, the wind is 300 at 12. At 940 millibars, the wind is 300 degrees at 20. 907, 295 degrees at 25, and so forth. Okay, so that's the break between the temperature data and the wind data, and that's the way all that data is transmitted. Now, do we still need radiosondes? Yes, indeed. It gives us an instantaneous snapshot of the atmosphere overhead, and it's an actual weather instrument. It isn't relying on a satellite remote sensing tool to try to calculate what the temperature is. We're getting a direct measurement using reliable instrumentation. It is also used as ground truth for the satellite measurements. In other words, we know that the instrumentation is accurate. We want to make sure that whatever the satellite is using for its calculations is accurate, and so it's actually used as ground truth for that. And only polar orbiting satellites can generate soundings or profiles of the atmosphere because they're only 300 to 500 miles off the ground. The geostationary satellites that we talked about the last time are 22,000 miles above the ground. And so they're way too far away to be able to generate this sort of detail in terms of producing an atmospheric sounding. Now, this is an animation of what a geostationary satellite looks like. And basically, it is rotating at the same speed that the Earth is, okay? And it has to be at 22,000, I think it's 632 miles, but it's an exact altitude so that it can move fast enough to stay in orbit, and it moves at the same speed the Earth does. So relative to the Earth, it stays over the same location, okay? Now, let me move on ahead to the polar orbiting satellites here. And here, you're taking a swath or a swipe as it circles the Earth from pole to pole, and so it takes some time over the course of a day to fill in all those holes, okay? There's spaces between those swaths, and you can see that as we go on in time here, that more and more of the Earth is covered, and so it finally gets to the point where, you know, the whole Earth has actually been looked at. But I think the orbital time is something like an hour and a half to 2 hours to go from the North Pole to the North Pole. So it takes a little bit of time to go all the way around enough times so that all those swaths cover the Earth and don't leave any holes. But the data they collect is very, very high resolution because it is not that far off the ground as opposed to the geostationary satellites. Okay, and you can see that those holes are just about getting filled in there. Isn't that nice? Took some time, didn't it? Okay, I think that's it. All right, so I hope that clears things up a little bit, and that's the YouTube, that's what happens on every YouTube video when it gets to the end, is I guess it gives you all sorts of other ideas as to things you can look at. But that is it for today. That's bonus weather video number 2. Hope that makes a little bit of sense about why radiosondes are still very, very useful. We'll be back Tuesday with another bonus weather video, and we will have the next daily weather update will be coming up on Monday. And just to recap that forecast for you, dry on Saturday, wet on Sunday. Definitely Saturday is the day to get out and do things outside. Okay, you have a wonderful weekend, everybody, and we will talk to you on Monday. You all take care.